In the murky heart of South American swamps lurks a living nightmare. A swamp constrictor that drowns, crushes, and swallows whole. This is the green anaconda, a predator that turns water into a silent grave. Tonight, we ask the question that haunts riverbanks. How can one snake drown, crush, and consume animals larger than itself? The answer hides in muscle, patience, and a brutal anatomy honed by evolution. Call it monstrous, call it magnificent. The green anaconda, Eunectes murinus, is part myth, part biological machine, designed to immobilize life and erase the sound of struggle beneath still water. Its hunting grounds are drowned forests, oxbow lakes, and flooded grasslands. A world where silence is a weapon, and every ripple can mean death for something unsuspecting. Imagine a dark coil tightening around a leg, a thrashing elk muffled by a slow mechanical compression. That image is reductive, but it captures the raw, crushing intent of this constrictor. Our curiosity is simple and brutal. What anatomical and behavioral tools let a swamp constrictor drown, crush, and swallow whole? Over the next chapters, we will dismantle that mystery, piece by piece. This snake is extreme not because it is cruel, but because evolution sculpted a predator, optimized for silence and stealth. A slow executor in a humid, unforgiving domain. Expect close, clinical observation mixed with dark fascination. We'll shift from visceral scenes of predation to microscopic details of muscle fibers and nerve pathways that enable such violence. Throughout, we'll reference field studies, autopsies, and the known biology of Eunectes murinus, grounding the horror in facts, not myth. This is deadly behavior with an evolutionary explanation. First, the machine. To drown and crush, the anaconda relies on a suite of physical specializations. We begin with the most obvious, its size and musculature. Green anacondas are among the heaviest snakes on Earth, with females reaching massive girth. That sheer bulk makes their coils lethal, converting body mass into relentless compressive force. Their muscles are layered for power and endurance, not speed. Slow twitch fibers dominate, allowing prolonged constriction that starves muscles and lungs of oxygen in a targeted, crushing hold. More than 300 vertebrae provide flexibility and grip. Each vertebra anchors robust muscles and ribs that function like a living vise, conforming around irregular shapes, legs, torsos, even whole bodies. Thick, keeled scales offer traction in wet vegetation and concealment in rippling water. That skin resists abrasion and helps maintain hold while the snake maneuvers prey toward its head. Their skulls are kinetic. Joints between bones allow extreme gape, and elastic ligaments let the mouth expand around bulky objects. Swallowing whole is a mechanical triumph of flexibility. Their recurved teeth are not for chewing, but for anchoring. Once prey is grabbed, these backward-facing teeth prevent escape, while coils begin their irreversible work. Inside, digestive systems are ready to dismantle massive meals. Enzymes and stomach acid ramp up like an industrial plant, dissolving flesh, bone, and hides over days or weeks. Anacondas endure long fasts between meals. Their metabolism slows to transform a single huge kill into energy for months. Another adaptation enabling predation on large, unpredictable prey. Muscle needs control. The snake's nervous system coordinates precision constriction and the slow, rhythmic tightening that compress lungs and circulation until life ceases. Heat-sensitive pits and mechanoreceptors detect faint body heat and vibrations. In murky water, these sensors are the eyes of a predator, locating prey even when vision fails. Vision is adapted for low light and movement detection rather than fine detail. The anaconda waits for motion or warmth, then springs with a precision that betrays its seeming sluggishness. Anacondas can hold their breath for long periods, operating as ambush predators underwater. This trait lets them drown prey efficiently while remaining undetected and calm themselves. Their circulatory system tolerates sudden pressures. Muscles work to reduce blood return from prey and to withstand forces during constriction. It's a biological pressure chamber at work. Anacondas often anchor part of their body to submerged roots or logs. That fixed point gives mechanical advantage, letting them curve and apply leverage to larger, panicked animals. Their mottled green and black pattern dissolves into aquatic vegetation. From the surface, they are invisible shadows. From below, they can be mistaken for submerged logs. Perfect ambush disguise. In water, they move like a ghost, barely rippling the surface. Stealth is their first weapon. Crushing is the inevitable second when a target wanders too close. Often, they wait at river edges for mammals, caimans, or birds to approach. A lightning lunge, a hooked bite. Then coils tighten in a ritual of systematic suppression. They will attack in water, too, forcing aquatic prey into shallow vegetation, where coils can immobilize limbs and bodies. Water becomes the anaconda's partner in drowning. Contrary to myth, constriction doesn't crush bones first. It disrupts circulation and respiration. With each breath, the prey fails to draw. Carbon dioxide rises and consciousness fades. When submerged, anaconda coils force the chest to collapse and prevent breathing. The victim struggles until water fills lungs. A slow, clinical suffocation orchestrated by a patient killer. Witness accounts record anacondas tackling juvenile caimans. The snake immobilizes the head region, then crushes, preventing the reptile from using the very jaws that might otherwise defend it. On bank ambushes, capybaras and deer are seized and dragged to water, where the anaconda's strategy finishes the job. Land becomes trap. Water becomes the execution chamber. Once killed, swallowing begins. The skull flexes, and inch by inch the prey glides past jaws that can unhinge. The process is grotesque in scale, but mechanically elegant. A large meal can take several hours to ingest. The anaconda's world narrows to a single, slow act: ingest, digest, rest. A triangle of survival that rewrites its physiology temporarily. After a feast, movement is clumsy and vulnerability increases. Metabolism surges to process the meal, demanding warmth and safety. The predator becomes temporarily prey to other threats. Anacondas are largely solitary. Territories overlap around productive waters. Encounters between adults can be tense. Silence and subterfuge remain their social currency. Ambush is the rule. They seldom chase. Energy is conserved through waiting, patience, and perfect timing. The three pillars that allow a constrictor to target bigger prey than itself. Mostly nocturnal, they hunt under cover of darkness when prey is less vigilant. Night amplifies their sensory advantages and the horror of a silent, unseen killer in the reeds. Human interactions are rare, but dramatic. Pets, livestock, or the occasional person can become targets. Fear grows from stories, but actual attacks are uncommon and often tied to desperation or disturbance. Adult anacondas have few natural predators. Jaguars and caimans might opportunistically attack, but such confrontations are risky and often avoided by both parties. After a large meal, their lethargy leaves them vulnerable. Jaguars have been observed preying on digesting snakes. Even apex predators exploit moments of weakness in this brutal cycle. Social behavior peaks during breeding. Multiple males may coil around a single female in what's called a breeding ball, a chaotic contest of endurance and force. Males entwine and push, each trying to align cloacas. These grueling contests are less about blood and more about stamina. The winner earns a chance at passing on his genes. Unique among many snakes, female anacondas are ovoviviparous. They retain eggs internally and give birth to live young, sometimes dozens at a time, each a tiny version of the water predator. Gestation can last months, during which the female's metabolism and physiology change dramatically. She bulks up to nourish developing embryos, often reducing her own mobility. Births are bewildering spectacles. Scores of writhing neonates emerge, immediately independent, each facing a hostile world where predation and starvation thin the cohort quickly. Young anacondas hide in vegetation and under debris, relying on cryptic coloration. Survival rates are low. Many fall to birds, fish, or larger reptiles long before reaching adulthood. There is little parental care beyond giving birth. The mother does not feed or defend the brood extensively. Nature's strategy: many offspring, few survivors. Growth is rapid when food is abundant. Juveniles can turn to fish and frogs, while adults graduate to mammals and caimans. Size is the currency of predatory capability. As they grow, prey selection shifts. Juveniles focus on small, frequent meals. Adults target infrequent but massive kills. Strategy changes with scale, a predator evolving with its own size. As apex or mesopredators, anacondas regulate populations of capybaras, caimans, and other mammals. Their presence shapes wetland community dynamics and influences trophic cascades. By controlling herbivore numbers, they indirectly protect aquatic vegetation and riverbanks, maintaining habitats that support countless other species. A brutal but stabilizing force. They compete with jaguars and caimans for similar prey. These interactions are complex. Sometimes predator and prey roles blur, as both species exploit opportunities in fluctuating wetland resources. Population sizes respond to flooding cycles, prey abundance, and human pressure. In good years, numbers swell. In drought or heavy hunting years, populations contract dramatically. Conflicts arise when livestock or pets are taken. Fear amplifies folklore. Killing snakes to protect assets can destabilize local ecosystems, creating unintended ecological consequences. Myths exaggerate size and ferocity. Fact: anacondas are powerful but opportunistic predators. They rarely hunt humans by choice, yet their capacity to drown and swallow large prey is real. Researchers documenting predation see patient, precise tactics: stalk, strike, coil, and drown. Chronicling these moments reveals a predator both elegant and terrifying in equal measure. Video and camera trap footage show slow, inexorable constriction. The sound of water and muffled thrashing becomes a signature of anaconda predation, a disturbing natural cadence. Their energy economy favors risk-taking for large payoffs. Chasing small prey is inefficient. Instead, they target big, energetically rich animals that sustain them for months. Drowning and crushing are effective because they neutralize mobility and defense. In water, prey cannot leverage limbs or claws, turning their own environment into a trap. Though solitary, anacondas form loose social bonds around hunting hotspots and breeding seasons. These ephemeral associations reflect resource distribution rather than true cooperative behavior. Competition becomes fierce when prey is scarce. Territorial disputes can escalate, and larger individuals tend to dominate prime ambush sites near deep pools and river channels. They coexist with large predators like jaguars, which may avoid direct conflict. This uneasy truce is mediated by habitat complexity and the distribution of food sources. Deforestation and drainage of wetlands strip the anaconda of ambush sites. Habitat loss compresses populations into smaller areas, increasing competition and the likelihood of dangerous encounters with people. Anacondas are hunted for skins and perceived danger. Illegal trade and targeted killing reduce local numbers and dismantle the ecological roles these snakes occupy. Remove a top ambush predator and prey populations can explode, degrading vegetation and altering wetland hydrology. The brutality of the anaconda, paradoxically, maintains ecological balance. Currently, Eunectes murinus is not classified as globally threatened, but local declines are common where habitats are altered or hunting pressure is high. Despite myths, many aspects of their life history remain understudied. True population densities, impacts of climate change on flooded cycles, and long-term effects of prey depletion. Effective conservation needs habitat protection, anti-poaching enforcement and community engagement to reduce conflict, and value anacondas as critical wetland stewards, not monsters to eliminate. Field ethologists watch a slow theater of survival, camouflage, patient strikes, and the disciplined application of coils. Each action is choreographed by millions of years of selective pressure. Anecdotes of enormous anacondas consuming pigs or deer fuel sensational headlines. While rare, these events are biologically plausible and highlight their capacity to tackle prey beyond human expectation. There are limits: gape size, oxygen deprivation of the snake while swallowing, and the risk of regurgitation or injury. Anacondas balance risk and reward with evolutionary prudence. Large meals can be fatal if the prey injures the snake internally, or if the snake cannot clear digestive challenges. Nature's gamble sometimes fails even for apex hunters. Internet sensationalism amplifies rare incidents into urban legend. Separating drama from data helps us appreciate the anaconda's danger without feeding irrational fear. Across Amazonian folklore, anacondas inspire reverence and fear. These cultural narratives reflect a deep human recognition of the snake's power and its presence at the edges of human habitations. Males invest heavily during breeding seasons, sometimes fasting for weeks while engaged in reproductive contests. Their energy expenditure reveals a high-stakes reproductive strategy. Females, larger and longer-lived, endure gestation and the metabolic cost of producing dozens of young. Their body becomes a temporary incubator, sacrificing mobility for reproduction. In the wild, anacondas can live over a decade. In captivity, with steady food and no predators, they may reach even greater ages. Longevity ties to size and resource availability. Mortality stems from predation on juveniles, starvation during droughts, disease, and human actions. Each life is precarious, despite the adult's terrifying capabilities. Unlike insects, anacondas do not metamorphose. Growth is continuous, each shed of skin marking a new phase in size and predatory potential. Fluctuations in anaconda numbers ripple across food webs. Their absence can produce herbivore overpopulation, vegetation loss, and altered water dynamics, showing their ecological weight. In non-native regions, large snakes can become invasive threats. Understanding native ecology is crucial to prevent unintended damage if animals are translocated or released by humans. Altered rainfall patterns disrupt flooding regimes that anacondas depend on, shrinking wetlands and forcing snakes into marginal areas where conflicts with humans increase. protecting wetlands, enforcing anti-poaching laws, and educating communities can mitigate threats. Conservation isn't sentimentality. It's pragmatic stewardship of systems where these predators maintain balance. Killing an anaconda to prevent a rare attack raises ethical questions. Do we eliminate a species' ecological role out of fear, or find humane, informed ways to coexist? Human expansion into wetlands creates the conflict. Responsibility lies in habitat protection and behavior changes, not in myth-driven eradication of a species doing its ecological work. The brutal mechanics of the anaconda force a dark reflection. Nature's violence is indifferent, efficient, and necessary. Understanding that brutality is part of ecological honesty. We are drawn to monsters because they show us our own fragility. The green anaconda embodies a paradox: repulsion and awe coiled into a single living form. Studying Eunectes murinus reveals principles of biomechanics, respiratory physiology, and predator-prey dynamics that inform broader biology and conservation science. When we film these scenes, we're watching evolution's solutions to survival. The drowning, crushing, and swallowing are not malice. They are strategies refined over millennia. Yet, recognizing strategy doesn't remove horror. Witnessing the silent end of a struggling animal beneath anaconda coils challenges our comfort and forces ethical reckoning. If you care about wild places, support wetland conservation and community initiatives that reduce conflict. Protecting habitat protects both prey and predator, and the balance between them. Learn the facts, not the folklore. Education reduces fear and knee-jerk killing. Understanding the biology of the green anaconda fosters coexistence and better stewardship. So how does the swamp constrictor drown, crush, and swallow whole? Through a combination of massive muscle, sensory precision, patience, and a digestive system built for extremes. The process is brutal but efficient. Ambush, anchor, coil, suffocate, swallow. Each step is a study in evolutionary specialization, tuned to the unique violence of swamp life. The green anaconda forces us to confront a truth we often avoid. Ecosystems depend on predators that operate with ruthless effectiveness. Their actions are necessary, if unsettling. In watching the anaconda, we glimpse the thinness of human dominance. In water and reed, another life writes endings we cannot control. A humbling lesson in our place on Earth. Remember the name: Green Anaconda, Eunectes murinus. Not a monster of fiction, but a complex predator shaped by environment and time, capable of turning noise into absolute silence. If the idea unsettles you, let it provoke action. Protect wetlands, question sensational stories, and respect the animals that maintain planetary balance through brutal necessity. The swamp waits, patient and indifferent. Beneath its glassy surface, coils tighten and silence falls. The green anaconda is both creature and force, a reminder that nature's appetite is relentless.